Here we go. Exercise 10B. Now, what should be circling around is your set questions. I will post that up on Schoology as well, so you have a digital copy. But before we start, or at least continue with 10B, I want to do one example and also recap what we learnt yesterday. So, let's recap what we learnt yesterday. What did we learn yesterday? Let's go with Hamish. What do you remember? What did we learn yesterday? Good. 3 factorial means 3 times 2 times 1. So that gives us 6. Why do we use factorials? Anna? Were you here yesterday? Were you here yesterday? Yeah. Why do we use factorials? What was it used for? Why do we need to know factorials in this exercise? Not sure. Let's go with Will. Good. Not combinations. What's the term? Arrangement. So it's to use to find the number of arrangements. And the reason why I'm being pedantic with the term here, the difference between arrangements and combinations. Combinations is like teams. Combinations, an example would be, let's say, Seb, Trent, and Oscar. It's the one team. That's team A. Okay, so that's one combination, right? But that doesn't change even if I said Trent, Seb, Oscar in a different order. It's still the same team. So that's a combination. An arrangement, on the other hand, this would mean that Trent, Seb, and Oscar is different. That's a different arrangement. So I have 2 arrangements there, but the one team. So one combination, but 2 arrangements. Okay, so in our exercise 10B, we're doing arrangements in this case. The next exercise is about combinations. Okay, so number arrangements. What's the name for it? What's another name for arrangements? What's another name for arrangements? Let's go with Trent. What's another name for arrangements? Starting with P.
Instead of arrangements.
Permutations, correct. Yep. Permutations.
Shout out YouTube.
Okay, now permutations. I taught you a formula yesterday. Technically 2 formulas, but there's a general formula. What was the formula again for permutations? How do you find the general formula for permutations? Anyone remember? Let's go with Rachel. What was the formula that you learned? Any of the formulas? Okay, give me one. Just say whatever you know. Very good. N factorial over n minus r factorial. This is when you have n objects and you want to choose r group out of it. So what does that mean? Let's say I had 5 objects. So let's go 3. 1, 2, and 3. I've got 3 objects up here. Okay, I've got a piece of paper, I've got a pen, and I've got a watch. 3 objects, right? Now I can choose whether in one go I want to take all 3, or I want to take 2 at a time, or I want to take 1 at a time. Okay? And that's what R means. So the group size and how many arrangements you want to do, it's the group size. So I can do a group of 3. So how many different ways can I do with a group of 3? How many different ways can I do with a group of 1? Okay, how many different ways can I do with a group of 2? It could be these 2, it could have been these 2, it could have been these 2. Okay, so that's what R stands for. So when we write permutations, we would say NPR, that's what it stands for. When they say the total number of items you have, which is N, and what's the group size, which is R, how do you calculate that? That was N factorial divided by N minus R factorial. Okay, I should put brackets in here in these 2. Now, why was this the logic? Remember, I told you that one of the examples I did was if you had 8 colors and you wanted to paint a flag where it only had 4 boxes, so you only get to choose 4 and you had 8 colors to choose from. Naturally, in the first box you can choose, out of the 8 colors, you can choose 8 of them. Then after you choose 1 of them, the next one would be 7, then 6, then 5. See, it's different to 8 factorial. It's not 8 factorial, it's actually 8 times 6 times 8 times 7 times 6 times 5. Okay, so it's actually missing 4, 3, 2, and 1. That's why we're dividing by the missing group. Okay, that's what I was showing. So that's where we stopped yesterday. I mentioned about factorials. because we're doing arrangements. I mentioned the difference between arrangements and combinations. Okay? Again, the name for it, which is permutations, and then I showed you what happens when you have a group that you want to choose. Okay, so you have n objects and you want to choose a group. What I haven't taught you as the last example is what if you have n groups, but in the n groups there's a restriction. Okay, so not only am I choosing 3 at a time, but maybe let's say I only want females first before I have males. Okay, before I choose, or males first before females. Then how does that change the number of arrangements? Okay, so let's do an example here. We're going to look at next one over here. Oh, not that one. I'm going to go back to all that later. Arrangements with restrictions. Let's have a look at this example. So how many different even 4-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8? Okay, so if you think about the total options you have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 options so far. So in total, you have 8 options. But what you want is you want to know how many different ways can I arrange 4 digits. So 1, 2, 3, 4. Okay, I've got 4-digit number where I want it to be even. See, that's a restriction. It wasn't just any 4 digits. I want to know how many different ways I can arrange 4 digits where they're even ones. Okay? Now that's the problem, because if I didn't say even, it would have been easy. It would have been 8, 7 times 6 times 5. And that's how many options for the first number? I have 8 of them. How many numbers I have the next one? 7, 6, and 5. Provided that I don't want to repeat the numbers. Okay, if I want to repeat the numbers, then it'll be 8, 8, 8, and 8. Okay? But now the restriction is that I'm saying I want it to be even, which is the problem. They already told me that I can only use the digit once. So it's not 8, 7, 6, 5, because some of them are going to be odd. So the restriction is that it has to be even. So how do I do this? First thing you have to ask yourselves is, how do you get an even number? How do you know if you have an even number? What do you look for? What's the first thing you look for if you want to know if it's even or odd? Sitting? The last digit, what does it have to be? It has to be an even number. Now, out of these digits, 1, 2, 3, 4, 5, 6, 7, 8, which one of those are even? Right, how many of them are even? No? Out of 1, 2, 3, 4, 5, 6, 7, and 8, which one of these are even? 4. Okay, I've got 2, 4, 6, and 8. Those are my options. So you told me for this number to be even, this has to be either a 2, a 4, a 6, or an 8. True? That last digit has to be 2, 4, 6, or 8. Those are my options. So how many options do I have there? Like Sydney said, there's 4 options and that last box. Now if it has to be one of these 4. See, I'm dealing with the restrictions first. I'm working with the restrictions. I'm saying, all right, for it to be even, I only got 4 options here. Now if there's only 4 options here, how many left over now? If I chose one of these numbers, 2, 4, 6, or 8, if I chose one of these numbers here, then how many options do I have left for the first number here? 7, because I chose one of them. Remember, there's 8 in total. I already chose one of them. One of them is 2, 4, 6, or 8. One of them's here. Then there's only 7 left here. If I chose 7 here, I chose another 1 here, then how many left do I have for the next one? 6. Then 5. See, the difference here compared to what you were doing before, this one now is 7 options, then 6, then 5. This would be the answer if I wanted to have even numbers. Okay? But if I didn't ask for even numbers, I just said 4-digit numbers, then you would have said, oh, well, if it's a 4-digit number and you have 8 options, then you have 8 in the first go, 7 different options after, 6, then 5. That's what you would have done previously. That's the previous, what we just came back, we just revised, that's what we would have done. Because that had no restrictions to it. But now, there is a restriction to it. Now that I'm saying, no, I don't just want any 4-digit numbers. I want 4-digit numbers that are even. So how do you make sure it's even? Make sure that it's going to be 2, 4, 6, or 8. Now if I chose a 2 here, then that means I only got 7 numbers left to play around with in the first box. Okay, yep. Yes, exactly. So if they say that I can use the digit more than once, then the only thing that changes is still 2, 4, 6, or 8 here to make it even. There you go. Perfect. That would be 8, 8, 8. Because if I can use it more than once, then I still have 8 options here. I can repeat it. And I can repeat it again, and I can repeat it again. But it's just that I've only got 4 options in the last box to make it even. So we 8, 8, 8. If this said you can use them all at once. That's good. That's exactly what you need to do. Yeah. And that I'm pretty sure some of the questions will ask you to do that. So they'll say use it once, use it more than once. And that's how you apply the restrictions and apply it to the context. Does that make sense? All right, cool. So that's just the last part of exercise 10B. That's what I want us to work on. But I'm going to do one more example just so we get a good feel of it. So let's do question 9. Let's do A. Find the number of ways in which the letters of the word trouble. Okay, so how many letters do we have? We've got 1, 2, 3, 4, 5, 6, 7. And they all don't repeat. No, I got 7 different letters. 7 options to choose from. I want to know how many of them can be, how many different ways it can be arranged if they are all used. Meaning that I don't repeat any of them. Because if they're all used, that means I can't repeat them, right? So how many different ways can I use them? I got 1, 2, 3, 4, 5, 6, 7. Now, if you really think about it, because they just said, I want to know all the number of ways to rearrange trouble, then in the first one, I should have 7 options in total. Then 6, 5, 4, 3, 2, 1. Okay, because that makes sense that I'm using them all. Okay, if I use one of the letters, well, now I've got 6 letters left to use, then 5, then 4, then 3, then 2, then 1. Yeah, so in this case here, it would be 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. So that makes sense. But what about B? So if they are used 3 at a time, what does that mean? Use 3 at a time. What is changing here? What's the difference between A and B? What am I changing, Lucy? Good. See, this is using all 7 at a time. Okay, but now I only want 3 spaces. I only want 3 letters that I'm going to choose. But I have 7 of them to choose from. So you fix your box and you say, all right, well, I only got 3 at a time. But out of 3 at a time, how many different ways can I choose them? Well, in the first option, I have all 7. Yes. Oh, not over 3 factorial. 7 over the formula that Rachel mentioned before. Yeah, good. It'll be n factorial over n minus r factorial, because remember, this has to be 7, 6, and 5. It makes sense that you want to remove 4, 3, 2, and 1. That's why you do 4 factorial. So if you really think about it, 7 factorial divided by 7 take away 3 factorial, which is 7 factorial divided by 4 factorial. That's why it makes sense when you break it apart. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. These cancel out. That's why. That's why the formula works, because we're just saying, if I want groups of 3, 7 take away 3, I have 4 left I want to remove. So that's why 4 and 4 factorial will cancel out, and then you're left with 7, 6, and 5. It's the same. Okay? So now, okay, so the answer would be 7 times 6 times 5. Those are my 3 boxes. How many options do I have in the first go? 7. How many options do I have in the second? 6 left. How many options do I have left? The third one, 5. That's the logic. This is the formula. That's how it works. So 7 divided by 7 take away 3. 7 take away 3 will remove the 4 last digits away. 4 factorial. Okay? And that's exercise 10B. How do we feel? Pretty good? Okay, so I'm going to get you practicing this session. We're going to do 10B. Next session, we'll then do 10C. We have a double session to work on combinations. And then we'll move forward. But I've given you the sheets there. It has 3 exercises in chapter 10, and then 3 exercises for chapter 11. Okay, so we're doing permutations, combinations, and applications for chapter 10, and then chapter 11 is about discrete probability. Okay? Well, there you go. I'll stop there. I'll go back to question, I think most of you should be about 3 and 4, if you've done 1 and 2, because 1 and 2 is just factorials, working with factorials, knowing how to use factorials. Number 3, starting to use permutations, and then as you move forward to the next few questions, 7, 8, 9, 10 is starting to do with the restrictions and options that you're choosing from. Okay?
Checking 10B Friday.
10B and 10C.
On Friday.
Yep.
Technically, they should give you 5.0. I haven't done 10C.
Oh, well, we haven't done 10C yet.
What? Oh, I need to do 14.